it's time for you to check your tables. So our first one is linear. That's y equals x, or f of x equals x. And all you do is replace your x into the x, which means you're getting the same exact value back that you started with. Our second is quadratic. When you work on your quadratic tables, you want to make sure that you are substituting x in parentheses, because when you square it with the square on the outside of the parentheses, that's going to give you your positive 9, your positive 4, your 0. This is 2.25 and positive 9 again. Similarly, when you take a look at this cubic function for the third one, you'll see x cubed here. And when you put this in parentheses, you're doing -2 times -2 times -2. That's going to give you a -8. -1 times -1 times -1 gives you a -1. This says -0. That's a typo. That's silly. There's no such thing as a -0. 1 cubed is 1, and 2 cubed is 8. Our next one is an absolute value function. And remember, when you take the absolute value of a number, that means you're looking at the distance to 0. So this is going to be positive 8. This is going to be positive 3. Absolute value of 0 is 0. Absolute value of 2 is 2. Absolute value of 6 is 6. And absolute value of 5.5 is 5.5. This one is the square root of x, which is a radical function. So when we're looking at the square root values, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 2 is approximately 1.41, and the square root of 0.5 is approximately 0.71. We round these to get just a pretty good idea so we can graph it better. For the rational or reciprocal function, that's 1 over x, you're simply just putting these values in the x position. So this is going to give you -1/2. This one's going to give you -1. When I do 1 divided by -1/2, I'm going to keep change flip, which is going to give me -2 for a final answer for that one. When I do 1 divided by 0.25, that's the same as 1 divided by 1/4. Keep change flip, and you're at positive 4 here. 1 divided by 1 is 1, and 1 divided by 4 is still 1/4. This one's called the greatest integer function. So we're looking only at the integers. So 0, 0, 1, 1, 2, 3, and 4. Only look at the integers. Our last one is an exponential function. That's because x is the exponent in exponential functions. So you're going to substitute 0 and 1 and 2 and 3, -1 and -2 and -3. Since we've done so much work with exponents pretty close to now, this shouldn't be too bad. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. This is 8. Remember, when you have a negative exponent, you got to bring it downstairs. We're going to bring it downstairs and square it. Bring it downstairs and cube it. There you go. Now what your job is going to be is to take these values and graph them on your provided graph paper so that you can get a visual for what your parent functions truly look like. Try and color code your tables with your graph so you can connect them.